Hi everyone, in this video I will talk about what is an Azure replication is and what are its types, and for each type I will give you an example so that you can understand it better. So let's get started with what an Azure storage replication is. As the name suggests, it is a kind of data replication, like creating a copy of your present data in another database or data center so that it can be preserved if something happens to our main layer. So to maintain the data availability and durability, Azure Storage create and store copies of the data across multiple locations. So this process is called as storage replication. The main goal of this storage replication is to provide redundancy to protect data against hardware failures or the power or network outages. So let's discuss about the types of Azure data replication. First is locally redundant storage, LRS. It replicates the data three times within a single physical location in the primary region only, and it is the most basic and cost effective solution of replication. I will give you an example about it. Suppose there is a small business that uses LRS for their non-critical data storage need. This replication type keeps three copies of their data within a single data center. Like all the copies are stored in the same data center only, and it is cost effective and provides protection against hardware failure within the data center. The main highlight point here is the data is replicated three times within a single data center, and it provides high durability and availability within the local region. And it is also least expensive replication option. Second, we have zone-redundant storage, ZRS. It replicates the data three times just like local redundant storage, but in the uh, same region. In the previous was the primary region. Whereas in zone redundant storage it is stored within the same region. I will give you an example about it. Suppose there is an e-commerce website that uses ZRS for their user transaction logs. It replicates their data across multiple availability zones within the same region. It ensures that the data remains accessible even if one zone experiences an outrage. The key points that we have to keep in mind here is that data is replicated across the three availability zones within the same region, and the data is protect against data center failure. Suppose there is a failure in the data center only, so our LRS will fail in these kind of conditions, so we use ZRS so that it if one data center got failed, then we have the data with us. It offers a higher availability and durability than LRS. Next we have geo-redundant storage, that is also called as GRS. It replicates the data to the secondary region also, providing the disaster recovery option if there is a major outrage in primary region. So I will give an example of this. There is a financial institution that uses GRS for their customer records and transaction histories. The GRS replicates their data to a secondary region also. If there is a failure in the one region, then the data is safe in the secondary region. And the region is hundreds of miles away from the primary region, which provides the additional protection against regional outrage and disaster. The key point is here that data is replicated to the secondary region, that is hundreds of miles away, and it provides high durability and disaster recovery capability. And the data is first replicated within the primary region using LRS and then asynchronously copied to the secondary region. Then we have Geo-Zone-Redundant Storage that combines the benefit of ZRS and GRS. It replicates the data across multiple availability zones in primary region and also to the secondary region. I will give you an example. Suppose there is a global news organization that stores their news and articles and media assets. This replication type not only replicates data to the secondary region but also allows read access from the secondary region. That ensures that there is a uh, content is highly available to the user worldwide and even during a regional outrage, um, uh, in which the data can be restored and there is no chance of destroying the data. That's it for today's video. Thanks.